Hi everyone, my name is Juan Pablo. Welcome to my YouTube channel. In this time, I would like to show you a functionality of a feature that it doesn't have a specific name, right? It doesn't have a specific definition name, but basically it's called import from default to a VRF and vice versa. So what does mean? It means that this feature allows us to import some routes from the default routing table into a VRF. So this is very, very common in providers, for example, that they have accessibility to the internet using the default routing table. They receive either the default route or the wall internet routing table in the PE devices. So they have access to internet over default routing table. And also those providers have customers. Those customers are subscribers that probably would like to access also to the internet, but those customers resides in a VRF, right? So whenever they reside in a VRF, then obviously they cannot jump into directly to the default routing table. So if we want to provide internet for those users, for those customers that are under a VRF, then we need to somehow pass a default route or all the internet prefix towards those users, right? And that's where this feature comes into the place. So this feature helps us to import either a default route or all internet prefix into that particular VRF, and then it will pass the prefix to the customer, right? Obviously, in real case scenario, the customer probably is not interested in receiving the whole internet routing table. So in those cases, we just import the default route under the VRF, and we just pass the default route to the customer, and then the customer basically reach to the internet. So, for example, in my topology here, I have internet, right? Just to give you and be a bit more exemplified here. So I have an internet route, so it's an eNet ASBR, and this represents the internet providers. And this eNet ASBR have a connection towards the provider's ISP James. This is a topology I normally use for my bootcamp, so it's the MockLab 1, in case you would like to join to some of the bootcamps. So in this lab, the eNet ASBR is connected to the ASBR 1. So ISP James, in this case, has this network, P1, P2, ASBR 1, and ASBR 2. And P1, for example, has a connection to a user that is under a VRF called green, right? So this VRF is configured in this interface, and I added under a VRF green. So this is the customer 1, okay? So this PE has a VRF and has a customer over there. Now, the eNet route or the internet is connected to the ASBR by this interface, and this interface is in the default routing table, right? So it's not under a VRF, it's just in the default normal routing table. Obviously, the ASBR has a peering session, VPN IPv4 as well with the route reflector. So the ASBR1 peer with the route reflector 1, route reflector peers with the P1, with the P2, and with the ASBR2, right? So in our case, for example, to help out to simplify the functionality of this feature, basically, we will suppose that the eNet ASBR, which represents the internet, is forwarding a default route to the ASBR1 over the BGP IPv4, right? Because between these two guys, the eNet ASBR and the ASBR1, there is an IPv4 BGP session, right? And over that session, the eNet ASBR is forwarding a default route. Now, the ASBR receives a default route from the eNet router, and then it will propagate, obviously, to the route reflector over the BGP IPv4 session that it has with the route reflector. Here, the ASBR1 has a configuration of next hop self, right? So basically, next hop self, if you know some basic of BGP, it will help out that the next hop will be totally changed to be the ASBR1 whenever this router advertises default route to the route reflector. Then the route reflector will see the default route in the BGP and will see ASBR1 as a next hop. Now, route reflector 1 will propagate this route to the P1, in our case, this default route to the P1 over the BGP, again, IPv4 session that P1 has with the route reflector, okay? Now, once P1 has this default route on the BGP routing table, right, what this feature does is basically, it has to be configured on P1, And what this feature allows us is that we want to import this default route under the VRF green. So in this case, if we import from the default route under or to the VRF green, then the route will be propagated to the customer C1, and then C1 will be able to reach out internet devices or prefixes, right? So in our case, what we will do is basically, the lab is already set it up, right? So inet ASBR is already forwarding a default route to ASBR1. ASBR1 is propagating this default route over BGP to route reflector. Route reflector is propagating the default route to the P1. And what we will do is just to do the import of this default route in the default routing table over the VRF green that is under this interface, right? So what we'll do is we'll go to P1, right? First, I would like to show you that few things. The ASBR1, for example, this has a session with ASBR, inet ASBR, sorry, has a session with the ASBR1 over this interface. This is the neighbor, right, of ASBR1. So to that neighbor, I basically advertise a default route, right? So it should advertise a default route. Yes, it's generating a default route for that neighbor. Now, if I go to ASBR1, ASBR1 is already receiving that default route with the next hop of inet ASBR, right? So now ASBR1 is propagating that default route to the route reflector, which has the 21, 21, 21, 21 advertised routes. And we are propagating the default route to the route reflector in ISP James. And obviously the next hop is being changed. So for example, if I go to P1, obviously the route reflector received the route and route reflector propagate to P1 because the route reflector is configured as a route reflector. So if I go to P1, P1 see the default route with the next hop of the loopback of ASBR1. The loopback of ASBR1 obviously is the 22, 22, 22, 22. Here, okay, so here the next hop is a bit different because ASBR2 is also propagating a default route. And the loopback of ASBR2 is 22, 22, 22. I will not change that now. The thing is that we have already the default route in the P1, right? So we are receiving for another ASBR2. And what we want to do is that we want to import under the VRF green. As you can see, I have a VRF green here. And this VRF green I have configured under the interface is the gigabit 001. So there is where I have the customer, right? So I have the customer C1, which is in the VPN green that you can see in the picture above. And then if I want to import a default route towards the VRF, then I need to configure the command import from default to the VRF. How I do that? Well, I need to join to the VRF and then address only IPv4, import from default VRF, and I have to define a route policy here. In this route policy, I can put basically a route policy where I will match the prefix that I want to import from default to the VRF. In my case, I will create a route policy default route 1. So I will create this route policy default route 1, and here I will just match the default route only, right? I will not like to import all the prefix. I will just want to import the default route. So then I configure that, and basically what I did is the following. I create a route policy where I will just import the default route under the VRF green, and under the VRF green I configure our feature that we are explaining today, which is import from default to the VRF. So this feature has to be configured under the VRF green, and then I just type this command import from default, specify the route policy, and then I will define what I want to import. Whenever I commit, because in XR you know that you have to do all commit, then C1, if I check in C1, which is the customer, then C1 of course should see the default route now coming from the PE1. And this is done because P1 is importing the prefix that receive obviously from the inet router under the VRF green. So that's how this feature works. As you can see, it's pretty easy, and it's very common in many service providers because they will just like to pass the default route to the users, and then users can access to internet quite easily. So I hope that you enjoyed the video and that you like the feature, and follow me for more videos, and thank you very much for watching.